Can we have
Electrical circuit.
beer for 200?
Electrical circuit with one current path.
Doug,
What is a series circuit?
correct.
Alright, so this is a simple circuit, and we should start off by looking for the sum of all the resistors. So in a series circuit, the total resistance is the sum of all the resistors. So RT equals 50 plus the 40 plus the 10. So RT equals 100. Okay, so we know RT equals 100 ohms, so I'll put that over here. Nice and simple. Alright, let's look for the current total. So we know in a series circuit there is only one current, so every resistor will share the same current, only one current path. So looking at this triangle, if we don't know how to transpose, there's a simple trick here. If we cover up over this I, so if we're looking for current and we cover up over I, it's V over R. If we're looking for resistance, it's V over I. If we're looking for voltage, it's I times R. Same over here goes with the power triangle. Alright, so IT, so current total, equals the 20 volts over the 100 ohms. So IT will equal, that should be 0.2 amps. Alright, so now we'll write that in again over here. Let's look for power total. Right, so we can do power equals IV. So we know it's 0.2 multiplied by the voltage, so 20, equals, that should be 4 watts. So we can put in 4 watts. Okay, so that's the basic parameters. What if we want to find the voltage drop across the resistors? So we'll take R1 for example. So we'll call that V1. V1 equals 0.2, so the current, multiplied by the resistance. So R1 equals 50. Equals 10. Volts. So the voltage across that resistor is 10 volts. Alright, we'll do the next one. So V2 equals 0.2 multiplied by the 40 equals, that should be 8. Okay, let's do the final one, V3, 0.2 multiplied by the 10, that should be 2. Alright, so now if we actually sum all these up, calculate that out, that's, you can see straight up that's 20. Look, and now you know, oh, that's correct. Now let's look for the power across each resistor. Look at each resistor's wattage. So remember, P equals IV. So we know the I, 0.2 multiplied, let's call this P1, 0.2 multiplied by the volts, So that's 10 equals 2 watts. Sorry about that, I just had to move my tablet. P2 equals again 0.2 multiplied by 8 equals 1.6. P3 equals 0.2 multiplied by 2 equals 0.4. Add them all up, you've got 4 watts. Yep, that's what we got here. They all work. So if these come out slightly different on your figures, it might be just a rounding error. Alright, if this helped you at all, consider subscribing and hit that like button. Anyway, thanks for watching.